Alright, let's continue with this review, and let's start with number 8. Alright, watch this one. This one's actually, I think, pretty easy. Right? There are some a little more difficult, like the next one, number 9, is quite a bit more difficult than this one. But this is pretty basic, pretty straightforward. There's not much to this. You just have to understand what this thing right here means. It's a division, isn't it? We call this a complex fraction because you got a fraction over top of another fraction. So we call it a complex fraction. And it's just basically a big division problem. So when you divide fractions, what do? You take the first one and you multiply by the, what's the word? Reciprocal. So we just rewrite it like this. We take the top, we keep the top the same. Instead of division, we multiply by the reciprocal. So you just flip the bottom one. That's what the reciprocal means. You just flip this. Alright, so I got an x plus 4 on the top, and I have a 4 on the bottom. It's not too hard, is it? Everybody should be able to get this one. And then you take a look at this and you say, alright, what do I do here? Do I cancel anything out? Always look to see if you can cancel stuff out. In this particular problem, can you cancel anything? Does the 4 and the 4 go? No. Alright, again, we've talked about this 100 times, haven't we? 4 doesn't divide with this 4 because this 4 is being added, so you cannot cancel the 4's out. Nothing else will cancel out, so we just multiply the stuff on the top. You could just write it like this, if you wanted to, or if you wanted to multiply the x by both of those, distribute the x through there, you could have done that as well. You didn't really need to. You can just keep it like that. That's all there is to it. Everybody can get that, can't they? I don't think one person in here should miss that on a test. Agreed? Okay, I think so. Number 9. Alright, let's look at this one. This is also a complex fraction, kind of similar to what we just finished doing, but with a little bit of a twist. What's the twist? Well, what you have to do is you're going to have to simplify that first. Yeah, find a common denominator, but before we find a common denominator, what do you think we want to do? We did this yesterday. Yeah, let's factor this thing right here, that p squared minus 36. Let's factor that thing. Okay, so really, technically we're trying to simplify the top, but before we simplify the top, we got to find a common denominator. Like Leslie said, we're going to add these fractions together. So what I need to do is I need to take this and rewrite it. Okay, it's kind of difficult. I mean, you could use this as your common denominator. All right, that would be fine because that's just a 1. But I think it's a little easier, to tell you the truth, to factor the thing. What kind of factoring is this? Difference of two squares, right? We've seen that a bunch now, haven't we? So you should get used to that. So let's just factor this thing right here. It's a difference of two squares, and then 1 is plus, 1 is minus. Put p and p right here, and then 6 and 6. Isn't that one of the easiest factorings that you do? Difference of two squares? Yeah, I think so. I always, when I see that, I'm like, yeah, it's easy. I don't have to think too much about that one. All right? And then we still have to put what? Plus p, or p over 1. And we'll just rewrite everything so we don't forget all this stuff. All right? But we're going to do that at the very last. That 1 over p minus 6, that's going to be the very last thing that we do. All I'm concerned about right now is trying to simplify this stuff here. Okay? So let's keep on going. We've got to find a common denominator. Well, if this is a 1, the denominator is pretty easy to find, isn't it? It's just that p plus 6, p minus 6. Now you have to ask yourself, you got these two fractions, right? What did you do to this denominator right here to get to this? Didn't really do anything, did you? Technically, you multiplied by 1, but you really didn't do anything, so I don't do anything to the top. So it's just a 5. Plus, now look at this. What did you do to this denominator, this 1, in order to get this whole thing right here? Multiplied it by everything, didn't you? All right, so what do you do to the top? Multiply that by everything, p plus 6, p minus 6. So what would that look like? P times p plus 6, and then p minus 6. Okay? Now, let's simplify this thing. See what we can do with this. Let's just leave that 5 right there. We'll add that a little bit later. And look at this. This p is being multiplied by these two, but remember what p plus 6 times p minus 6 is? Just p squared minus 36, correct? Now remember what we do on these, okay? Kind of like these style of problems, you always simplify the top, all right? Always multiply it all out and see what you get. The bottom you can just keep at p plus 6, p minus 6. There's really no reason to multiply the bottom out. All right? Because up here you might have some things that are like terms. Let's see, this is going to be... Really, to tell you the truth, this doesn't really simplify anymore, but we'll just multiply it all out. So let's see what the best way to write this answer is. So I got a 5 plus, and then go ahead and take this p and distribute it through here. So that gives you what? P cubed. Is that right? Minus 36p over, and then that p plus 6, p minus 6. Nothing's going to cancel anyway, right? Because all this stuff was being added to the 5, so nothing will cancel. Like this p minus 6 will not cancel with this p minus 6 right here. Because if you look at this whole thing right here, this whole product is part of a sum, isn't it? This is all being added to something else. So this p minus 6 will not cancel with this p minus 6. This p plus 6 will not cancel with this p plus 6. Why? Because the whole thing is part of an addition problem. Some people look at this and say, yeah, but p minus 6 is being multiplied by p plus 6. And you got a point. But you have to look at the whole entire product, that whole entire thing that's being multiplied together. What's happening with that? Is that the only thing that's going on up top here? No, it's not. Okay? Even though that stuff's being multiplied, it's part of an addition problem, so those will not cancel out. And that's a big, you know, and I say that over and over and over again. Okay? Earlier we said that that 4 didn't cancel out or something, right? Yeah, like right here. Remember I said that right at the beginning? I said that 4 does not cancel out with that 4 right there. And I say it all the time, and you probably get tired of hearing it, but I need to repeat it because students all the time will cancel stuff out when you're not supposed to. Alright, so that's it, isn't it? There's nothing I can do. There's no like terms I can add. So I guess that's the best way to write this. Technically. Oh, wow, I sure do. How about that? Thanks for reminding me. And that was my fault. Because even up here I said, hey, let's make sure we write everything down so we don't forget about it. And guess what I just did? I completely forgot about this thing. So, see, all this right here I should have put over 1 over p minus 6, shouldn't I? And it's a good thing you reminded me. And that's, look, I didn't do that on purpose, for sure. But, you know, if I can make that mistake, you definitely could make that mistake as well. So let's remember to put that in there. And then this is going to be over 1 over p minus 6. And to tell you the truth, now that we did that, no, that's good. So now what we're doing, we're trying to simplify this. That's not the answer. I didn't put a box around it because that's the answer, but that's what we're trying to simplify. All right? So let's take a look at this. So how do I simplify this thing? Well, this is my fraction, isn't it? See, I got this top, that's the numerator, and that's the denominator. So, just like we did on the problem before this, we multiply by the reciprocal. So let's write all this down again. I mean, it's a little bit of writing on this, but really the steps aren't that difficult, I don't think. It is a little bit of writing, though. It does take a few steps. Now watch what we're going to do. Instead of dividing by this thing right here, what are we going to do? We're going to multiply by the reciprocal. So p minus 6. Now watch, if I'm taking this p minus 6 and multiplying it by all this stuff over here, I'm going to put that p minus 6 in parentheses. Put it over 1. We good? So this is all being multiplied by this. So even though you have plus and minuses in here, you're taking that whole entire product, it's being multiplied by this, or I'm sorry, not product, but this sum right here is being multiplied by this sum. Since they're being multiplied together, I can cancel stuff out, can't I? Everything on the bottom is all being multiplied. Even though you have pluses and minuses in here, this thing right here is being multiplied by this. So you can cancel stuff out. So what cancels out here? P minus 6 and the p minus 6. And then what you have left is your final answer. Is that how they wrote it? Yep. Over p plus 6. And that's it. All that just to get that weird looking answer. Alright? Alright, it's recorded. It's online. Go look at it. Stop it, review it, take some notes, try to figure out what you're going to do next. All right, that's the best way to use these videos. You sit there, don't just sit there and, we talked about this yesterday, but don't just sit there and watch it like a TV show. Okay, be interactive with it. Stop it. Once you get to the next step, pause it, try to figure out what the next step is. Okay, play it again. See if I did the same thing that you did. Okay, if you did something different, go back and try to figure out what you did wrong. That's the best way to view the videos. It's not just to sit there and watch it like a TV show. All right, you're not going to get anything out of it. You've got to be interactive. Okay, you've got to. It's a participatory. Did I say that right? Didn't say it well, but got to participate. All right, let's go through the rest of these. Now we're doing exponents. Okay, now we're kind of changing gears here, and we're doing exponents, negative exponents, fractional exponents, all that good stuff. So number 10, it's 1/2 to the negative 4th power. All right, here we go. Listen to what I'm telling you right here. Okay, it's not difficult. You just have to know what the steps are. Because again, I remember these problems on the quiz. People are messing this up, doing crazy stuff, and I've told you the easiest way to do this. When you have a fraction taken to a negative exponent, all right, to a negative exponent, we don't want a negative exponent. We want a positive exponent. So we're going to flip stuff. But if you have a fraction right here, what do? We just take that fraction, flip the fraction inside of this parentheses. So flip the fraction and you get what? Just get a 2. Now, once I flip this, what do I have to do with my exponent? Got to change the sign of the exponent. So instead of negative 4, it's what? Positive 4. All right, and then you just do that. 2 to the 4th is 16. That's all there is to it. There's no reason not to get that, is there? Doesn't that seem simple? Yeah, it seems simple because it is simple, right? If it's to a negative exponent, flip the fraction, change the sign of the exponent, and then just work the thing out. All right. Number 11. This is kind of the same deal. It just takes it a little step further. But the initial first step is going to be the same. Now look at this. You still have a negative exponent, right? But look at your exponent. It's a fraction. It's a fractional exponent. So first thing, let's deal with the negative. Okay, let's forget the fraction right now. Just deal with the negative. So what am I going to do with this fraction right here? I'm going to flip it. That's right. So flip it. Change it to a positive exponent. Notice I didn't flip the exponent, did I? I just took the stuff inside the parentheses, flipped that, changed the sign of the exponent. So this and this are exactly the same thing. But now you got to figure out what to do here. This is the little extra that number 10 didn't have. All right? So let's take a look. We got to break this thing down. We don't want it to the 3/2. What we're going to do is write it like this. We're going to write 25 over 4. We're going to take it to an exponent. What's the first exponent we're going to take it to? To the 1/2. That's right. We have to take it to the 1 over the denominator power. Whatever the denominator is, we take it 1 over the denominator. I'll let that sink in for a second. Everybody see that? So if you have a fraction like this, okay, you always take it to 1 over the denominator first. Make sense? Now you can take that whole thing. What are we missing? We took it to the 1 over 2 power. Well, we need that third power, don't we? So now we take it to the third power. What allows us to do that? Well, remember the rules for exponents? If I have an exponent being taken to another power, what's the rule? What do we do with those exponents? We multiply them, right? We multiply the exponents. So what is 1/2 times 3? It's 3/2. Is this the same thing as this? Absolutely. Okay, we just broke it down to make it a little easier for us. Now remember, these things are all rigged, aren't they? Look at this. They didn't just pick 25 and 4 out of the blue, did they? They picked it because look what we're doing. We're taking it to the 1/2 power. What are you doing to a number when you take it to the 1/2 power? It's taking the square root of it. That's right. You're taking the square root of it. All right? You understand why they rigged this? They make it real easy, didn't they? So really, what is this saying? This is saying take 25, take the square root of 25, because to the 1/2 power means the square root of 25. To the 4 to the 1/2 means the square root of 4. So let's do that. What's the square root of 25? Just plain old 5. What's the square root of 4? It's just plain old 2. So we took care of that 1/2 right there, didn't we? But what's left over? The cubed. And so now we just cube the thing. That's easy. 5 cubed, 5 times 5 is 25, times 5 is 125. Is that right? 25 times, yeah, it is. 25 times 5, yep. 2 cubed is 8, and bang, I'm done. Here it is. Just like that. Know the rules. Basically 2 rules here, wasn't there? Change the sign of the exponent, and then this fractional exponent, we break it down. So basically, 2 rules that we've learned before. All right, let's keep going. Number 12. Same kind of deal. This is actually a little easier than what this one was. This probably, the order of these might have been switched if we're going from the easiest to the hardest. Let's take a look. You should be able to do this now, right? You don't have to flip anything, do you? Because you don't have a negative exponent. So we're just going to break this down into 27 to what power first? 1/3. Everybody should see that. I said up here, if it's to a fractional exponent, you take it to the 1 over the denominator, correct? Look at the denominator, it's 3, so you take it to the 1 over 3 first. Then you take this thing to the 4th power. And let's work this thing out. 27 to the 1/3. Now we said to the 1/2 was the square root. What do you do when you take it to the 1/3? It's the cubed root. So what's the cubed root of 27? You should be able to do that in your head. 3. What times itself again is 27. 3 is. 3 times 3 is 9 times 3 is 27. So the cube root of 27 is 3. But then you got to take this to the 4th power. And you just work this thing out. This is an easy one to do in your head. Because 3 times 3 is 9, right? And then another 3 times 3 is a 9. So 9 times 9 is 81. Just like that. Have we even needed a calculator this whole entire 1 through 12 yet? No. Yesterday I don't think we used a calculator once, did we? Or didn't even need one. We haven't needed a calculator here at all. Okay. Let's keep going. Let's go with this green. 13. Alright, more fractional exponent. Alright, let's take a look at this one. What do I do? What do I do? Well, this is what I would do first. Look at the numerator. I would simplify the numerator. Actually, you know, I wouldn't. I think it might be easier if I do it this way. Look at this. I see 5 to the negative 2/3 on the top, and I see 5 to the positive 1/3 on the bottom. So what I'm going to do is I don't like that negative exponent, do you? So what are we going to do with that negative exponent if we have a big old fraction like this? I'm going to flip it, right? So take this, and we're going to flip it to the bottom. And that becomes 5 to the positive 2/3. And it goes away from on top. Everybody seeing that? It's not hard, is it? Okay, if it's a negative exponent, you flip it to the bottom, change the sign of the exponent. That's all there is to it. Alright, the 5 to the 5th, I can stay here for a second. What about this stuff right here? Yeah, you could flip either this one to the bottom, this one to the top, or you can flip them both, right? Since they're both negative. But you really don't have to flip them both. Which one can you flip to the other side and still make it positive? The negative 7th, that's right. I can take this, flip that to the bottom, that becomes x to the positive 7th, and then when I multiply these together, I still get a positive exponent, don't I? If you wanted to, you could take the x in the negative 2nd, flip it to the top. You're still going to get the same answer, but I think it's a little easier. It's a little more streamlined, isn't it? If we just take this and flip it to the bottom. Are we good with that? These give people a lot of problems. I'm not really sure why, because it's really not that tough. You just have to be careful. You can't just do everything in one step and be done with it. All right, you just got to be careful with this. You flip it to the bottom. Now let's see what we have. On top, what do we have? We have 5 to the 5th, don't we? On the bottom, we got to do this thing right here. So the base is the same. Again, some of you guys are not getting the rule for this. If the base is the same, you keep the base the same, and you do what to the exponents? Add them up. What's 2/3 plus 1/3? It's 1, isn't it? It's 3/3, which is a 1. So that's 5 to the 1st. All right, just basic arithmetic. Not difficult at all. Now we can do this thing right here. X to the negative 2nd times x to the 7th. Add the exponents, and it's x to the 5th. We're almost finished, aren't we? You don't have to, but I like to do that because the rule that's coming up next, if people don't see it there, some people don't understand that it really is a 1 there. So I like to put it there. So 5 to the 5th over 5 to the 1st. Well, one of these 5s cancels out with one of these 5s, and I'm left with 4 of them. Or you could just subtract the exponents, right? Keep the base the same, subtract the exponents since it's division. I kind of like to do what I did right there. So what's left on top? 5 to the 4th. On the bottom is x to the 5th. Now 5 to the 4th is a relatively larger number. If you just want to keep it 5 to the 4th, I'm fine with that. I don't even know what that is. I know 5 cubed is 125. 125 times 5 would be what? 625? Okay, that's what I thought it was. And if you want it, if you really want to put 625, that's fine as well. I would accept either one of these. Okay, I'd be fine with either one. If you just want to keep it 5 to the 4th. Now, if it was something simple, like 3 to the 4th, you should have been able to do that in your head pretty easy. Like if it was 2 cubed, you should be able to do that. If it was 5 squared, you should be able to do that in your head. All right, as they start getting a little bit bigger, you can just write it 5 to the 4th. That's fine. But either way. Okay. Let's do 14 now. All right, this looks pretty close to what we just finished doing. So let's do this kind of quick. Look at the x's right here, and they made this really straightforward for you. You got the x's on top of each other, the y's and the z's all on top of each other. Okay, so all you got to do is decide which one do you want to flip. On this one, I'm going to flip this one down to the bottom because that becomes x to the positive 4/5. I'm not doing this in another color like I did this, but you can see what we do. And this is going to give you a positive exponent, won't it? You don't have to take that x to the negative 5th and flip it up to the top. You can just keep it just like this. Okay? What about this one? Which one do you want to flip? Well, obviously, the negative one. Flip the negative down to the bottom. So take this one, flip it to the bottom. So that gives you y to the 1/3. And that goes away. What about this one? Which one are we going to flip? The negative one. So we're going to take this, flip it to the top, and it's going to be z to the positive 5/6. That shouldn't be a big problem, should it? We just take the negative exponents and you flip them. If it's on the bottom, flip it to the top. If it's on the top, you flip it to the bottom. Not that difficult. Once you flip it, you got to change the sign of the exponent, though. All right, so let's see what we got on top. We got z's on top. So you keep the base the same and you add the exponents. 7/6 plus 5/6. Again, they make these really easy for you because they put all common denominators here. You didn't even have to find a common denominator. They already made it that way. 7/6 plus 5/6 is 12/6. 12 over 6 is 2. So I'll just write it z squared. Look at the x's. This is going to be x to the 4/5 times x to the negative 1/5. What do you do with the exponents? Add them together, right? I did write that right, didn't I? X to the negative 5th, yeah. Okay. And that's going to be x to the what? 3/5, because you just add the exponents. 4/5 plus negative 1/5, right? 3/5. Simple. Y is, look at this, just add the exponents. 1 plus 7 is 8. 8 over 3 doesn't simplify, so I just keep it 8 over 3. That's all there is to it. No reason to miss those. No reason at all. 15. More of these exponents. I don't know about you, but I kind of like these. For some reason, students don't like these kind of things, but if you just remember a couple basic rules, it just follows all through these problems. Maybe students don't like them because they don't learn the basic rules that we taught. Let's do this one. This is just distributive property, isn't it? So let's distribute. Boom, boom, right here. So multiply these together, keep the base the same. When you're multiplying with the same base, you keep the base the same, you add the exponents. So 4/9 plus 3/9 is 7/9. Easy. Let's multiply the last together. Well, I got a 4 out in front, so I got to put the 4 there. Now I got the y, so I keep the base the same, and I add the exponents. 4/9 plus 2/9 is 6/9. 6/9 reduces, though. I think when I read it off, didn't they write it as 6/9? Okay, you could keep it like that, but I don't know. I always like to simplify. So what would that be if I simplify that? 3 goes into those 2/3, right? So that probably is the way I would write the answer. If you write 6/9, I probably wouldn't mark it wrong. That's it. Some of these just take a matter of seconds, don't they, to do. Some are a little longer, I understand, but some of them just take a matter of less than a minute. 16. I'll just write this one out. M to the negative first minus n to the negative first over. Oh, you remember these problems, don't you? You had one like this on the quiz, didn't you? Okay. Give a big long talk about this. Remember what I said about these things right here? I don't just take this and flip it to the bottom. Why not? I did on those other problems because you got a subtraction in here. Look at all those other problems we just did on those last couple, actually on like 13 and 14. I flipped stuff down to the bottom because what was going on the top and the bottom? Everything was being multiplied, wasn't it? That way I can flip it down to the bottom. But on this one, You got a subtraction in here, so I can't just take this and flip it to the bottom. So I just treat this if it was sitting there by itself. What if you just had m to the negative first and somebody said, make that into a positive exponent? How would you write it? 1 over m, right. 1 over m to the first, or just 1 over m, right. So I'm going to take this and just write it 1 over m. Everybody seeing that? Okay. If you're awake and paying attention, that should make sense to you. Just going to take this and make it 1 over m, because the negative exponent, right? Don't flip it to this bottom right here. Just take this by itself. Pretend that nothing else was there, and you're just trying to simplify that. It's 1 over m. Now, if that makes sense to you, then this makes sense to you. What's that going to be? It's going to be 1 over n. Got it? It's easy enough. And then let's do the same thing here. Let's not take this and flip it to the top, because I got a minus up here. I'm just going to rewrite this. Pretend nothing else is there, and that's the only thing that exists. How would I simplify that? I would write 1 over mn. That's your first step. That's a major step right there. It's not a difficult step, but it's a very, very important step that you do it like that. Here's the hardest part coming up. It's just adding these two fractions together. And really, is that difficult? Add two fractions with little denominators like this? I hope not. All right, we'll do the big old fraction bar. The bottom we're not going to mess with. I'm just going to keep it like this. Now let's do the top right here. If I was to add these two fractions together to find a common denominator, it would be mn. I'm not going to take forever to show you why that's the common denominator. That's just basic fraction work that we've talked about over and over again in here, besides learning it in 5th and 6th and 7th and 8th grade. Okay. So now what do? You take that m. What do we multiply m by to get mn? Multiplied by n. So what do we do to the top? Multiply that by n. What do we multiply n by to get to this? Multiply by m. So you do the same thing to the top. Just like that. Now we've got a problem that's just like the problem we did earlier in here, didn't we? One of the first problems we did today, I think. I think the first problem was this. It's a complex fraction. So we take the top divided by the bottom. So here's the top. But instead of dividing by the bottom, we've talked about this at least twice today, we multiply by the reciprocal. So it's mn over 1. Look what happens. This one kind of works out nice, doesn't it? Because what happens? This is being multiplied, so this is being multiplied by something. So I am allowed to cancel it out from the top and the bottom as long as it's being multiplied. So that will cancel with that, and look what I'm left with. Just n minus m, that's your answer. Let's keep going. Again, if I'm going a little quick here, go on YouTube and watch them. Square root 150. Now here's what I would do. I would take 150 and break it down. All right? It ends in a 0. It ends in a 0, so I would do it like this. I would go 15 times 10. Just kind of makes it easy. You could take 2 into it, right? 2 goes into it, right? 5 goes into it. But I see it ends in a 0, so I think 10 goes into it. What about 15? Break that down. 3 times 5. What about 10? It's 2 times 5, right? So let's rewrite this. Let's clump the stuff together that can be clumped up. All right, so we got a 2, 3, and a couple 5s. Right? It's not that hard, is it? Okay. Then you look at here. What do we do? It's a square root. So we pair them up. Remember that? If it's a square root, we pair them up. So what's the square root of 5 times 5? It's just plain old 5. It's the whole number 5, isn't it? So that leaves the square root and comes outside the square root. Can I take the square root of 2? No. Can I take the square root of 3? No. So what do I do with those two numbers? Multiply them together. 5 squared is 6. Bang. You're done. Make sense? Alright. I hope so. What color haven't we used? Have we used that green yet? We're getting there. I think we'll just barely have enough time to finish these. Okay, we've got that. Here, let me pause this. Alright, here we go. Let's simplify this thing. This thing won't simplify any further, so I'm just going to keep it 4 times the cube root of 5. This probably will simplify right here. So let's come over here off to the side, and then let's break this down. Very similar to what we just did on that other problem. So I'm going to take 135 and break it down. I don't know, 5 goes into it, right? Ends in a 5. I don't know what that is off the top of my head. Somebody do that. What's 117? Okay, so it's 5 times 17. All right. I was going to say, I don't think it's 17 because, I know, it's 27, is that what it is? Okay. Alright, so 5 times 27. Yeah, that's right. Yep, 15 and 10 and 3. Yep. Yeah, that works. So, and then break this down. Well, actually, you can just keep it 27 because I'm taking the cube root, aren't I? Do you recognize 27? We've used that quite a bit, haven't we?
Didn't we just use it today?
Probably.
For number...
So what is it? 5
12?
times 27, right? So yeah, let's just keep it 27. I don't have to break it down into 3 3s, do I? Because I know the cube root of 27 is just a 3. What about this? What about 40? Break down 40. Well, it ends in a 0, so 5 times what? 8. Now, I picked 5 times 8 for a reason, because remember what I'm trying to do. I'm taking the cube root, right? 8 should be a number that you recognize by taking the cube root. So we've got this. We've got the cube root of, what? 5 times 8. Do you see why I left it 8? I could have gone 2 times 2 times 2. Would have been the same thing. Let's keep going. Plus, what's this going to be? You got a 3 here, don't you? And what can I simplify? I can simplify the cube root of 27. What's the cube root of 27? It's 3, isn't it? All right, let's do a little bit of this in our head. So this right here is going to be a 3 times this 3 gives us a 9. You can do that part, right? You don't have to write a whole step for that. What's left over then? Cube root of 5. Look, that's cube root of 5, right? Again, they rig these, don't they? So they add up real nice. Look at this one. Do the same thing here. What's the cube root of 8? It's just a 2. So it's 2 times the cube root of 5. So all I did was take this and this, simplify them both. That's really all I've done so far. Haven't even started adding anything. Now I can add. Are they like terms? Remember, we can only add like terms in algebra. Yeah, they're like terms. This is cube root of 5, cube root of 5, cube root of 5. It's just like saying 4x plus 9x minus 2x, isn't it? It's just like saying that, except our x is the cube root of 5. So 4 plus 9 is 13, minus 2 is 11, cube root of 5. And there it is. So I think the hardest part was just getting from here to here. Getting from here to here. If you can do those two things, adding them up wasn't the big deal. That was the easy part, adding them up. It was getting from there to there was the part that's a little bit tougher. Alright, we're almost there. Let's go back to white. Number 19. Okay, here we go. It says to add these up. It says to simplify, but basically we're adding up these fractions. We've got to find a common denominator, right? Well, look, the denominators don't even look close to being common right now, so what are we going to do? We're going to simplify these things. So let's simplify this, and let's simplify this. This is already simplified. Minus. Let's see if we can do this in our head. Remember, we're taking the square root this time, right? 9 times 3, right? What's the square root of 9? 3, so it's 3 square root of 3. Hopefully at this point, you should be able to do that in your head. You should be able to do the same thing with this next one, shouldn't you? 4 times 2, right? I'm sorry, 3. 4 times 3 is 12, so the square root of 4 is 2 square root of 3. We good? Common denominator. Look, they all have a square root of 3 in common, don't they? Let's do the numbers, though, first. I got a 1, a 3, and a 2. It'd be 6. And then they all have a square root of 3 in it. So there's just one square root of 3 that shows up, so I just pick one of them. Now, what did we do to this to get to this? Multiply by 6, so we multiply that by 6. What do we do this one right here to get this? Multiply by 2, so we multiply that by 2. See how easy this is? What do we do to this to get to this? Multiply by 3, so we multiply the top by 3, which is 6. Okay? Oh, is it plus? Sorry. Thank you. Alright, so what do we got here? I got positive 6 minus 6. Well, that's a 0, right? And then I got 8. So I got 8 over 6 square root of 3. Well, let's simplify that. What goes into 8 and 6? 2 goes into that 4 times. Into that, what? 3 times. So what do I have? I got 4 over 3 square root of 3. Am I going to leave it like that?
No.
I got to do what? What's a fancy math way to say it? We have to rationalize the denominator. Very good. So I know I'm going a little quick because time's running out on us. So multiply the top and bottom by the square root of 3. And then, oops, let me get the right marker here. Alright, so yeah, it's 4 square root of 3 over, now let's see what we get. Square root of 3 times square root of 3 is 3. Times this 3 is 9. There it is. This doesn't seem so bad now, does it? Gotta practice. Practice makes perfect. You know what they say? Alright, number 20. Go with the gray. Can you see that gray alright up there? 8 minus the square root of x. We'll add a little flash of color here with this. Alright, now, how do we get... It says to simplify. It says to rationalize the denominator is what the instructions say. So, I don't just multiply by the square root of x on top and bottom here because this is a sum. And some of you guys tried to do that on the quiz. I mean, it was like minutes after we talked about this in class because we reviewed for that quiz just briefly, didn't we, before we took the quiz? And some of you guys just still multiplied by the square root of x on top and bottom, but you can't. What's the fancy math word that we use for this? Multiply by the what? Starts with a C. It's called the conjugate. We multiply by the conjugate. What is the conjugate of this? It's 8 plus the square root of x. We talked about this quite a bit. Go back in the videos and look. Alright, let's go back to gray here. Alright, let's see what we get. Let's multiply these together. These should be easy to multiply together for you. It's a difference of 2 square kind of thing, isn't it? So when we multiply by the conjugate, the outside and inside actually go to 0. So all we got to do is multiply the first and the last. So the first is 64 minus the last is just an x, isn't it? Square root of x times square root of x is just x. What about the top? We got to distribute this through. So I've got 8 square root of x plus square root of x times square root of x, just like we said, is x. Does anything cancel out here? No, these don't cancel out because it's a sum, and that's your answer right there. Woo, we did it. Did them all. How's that? All right, so that part B, say it. 8 square root of x? Yeah. Yeah, well, no. If this was like the square root of 3, you would just leave it 8 square root of 3. Okay, because that's a whole number, and you can't really multiply it by a square root, so you just leave it 8 square root of 3. All right. That part B I gave you yesterday. Bring that tomorrow. We'll go over the answers to that, and then we'll take any questions that you have tomorrow.
Michael Gaynor, Bria's good.